For my ISP, I'm going to be talking about the product rule. Essentially, the product rule is f primed at x times g of x plus f of x times g primed at x. This means that you are doing the derivative of the first times the second plus the first times the derivative of the second. We are going to begin with a relatively easy example. It's going to be 4x minus 3 times 5x squared plus 7x. You're going to think that this is f of x and this second part is g of x. So to begin, the derivative of the first part, so it's just going to be 4, as this becomes 0 and this is multiplied by 1, times 5x squared plus 7x, plus f of x, which is 4x minus 3 times the derivative of 5x squared plus 7x. And you're going to move this 2 down, multiplied by the 5, which is going to be 10x plus 7. Right? Oh, these markers. Now, you're going to simplify it even further. So you're going to multiply the 4 using distributive property. So it's going to be 20x squared plus 28x plus, and then you're going to factor this, which is going to be 40x squared plus 28x minus 30, which is negative 2x minus 21. Then you're going to collect your like terms. So it's going to be 60x squared using these two. 28x minus 2x is plus 26x, and then you're left over with your 21. And this is f primed at x. That's your final answer. The next example, we are going to use the product rule, and then we're not going to simplify it as they would get very complicated. So we're going to have 8x cubed minus 5 multiplied by 3x plus 1 to the 7th. And this is what f of x is. So our f primed at x is going to be the derivative of this first value, which is 3 multiplied by 8, which is 24. X squared, as you're minusing 1 from 3, minus 5, it becomes 0, all multiplied by the second value, which is 3x plus 1 to the 7th, plus 8x cubed minus 5 times the derivative of this. So we're going to do the outer function first, so it's going to be 7, 3x plus 1 to the 6th, and then you're going to do the derivative of the inner function, which will just be 3. Our next example is going to be 3 minus 2x minus x squared, and x squared plus x minus 2. Once we are done finding the derivative of this, we are going to then plug x equals negative 2 into the equation to get an actual integer value for our answer. So f primed at x is equal to negative 2, as this 3 becomes 0, minus 2x, you're moving that 2 down, plus just g, or multiply by just g of x, plus x minus 2, plus f of x, which is 3 minus 2x plus x squared, and then the derivative of g of x, which is 2x plus 1, as there's always a 1 in front of that x. Then you're going to find dy over dx, where x is equal to negative 2. And it's going to be negative 2 minus 2 to the negative 2. It's going to get a little complicated, but the math is actually very simple. You just have to make sure you're keeping track of all your minuses. And that's going to be negative 2 squared plus negative 2 minus 2 plus 3 minus 2, negative 2, plus negative 2 squared, all over 2 times negative 2 plus 1. We're then just going to simplify this expression even further. We just have to make sure we're keeping track of all of our negatives. So negative 2 minus 4 plus 4, is going to give us 2. This bracket is going to give us 4 plus 4. It's going to give us 8, added 2, 3 plus 4 plus 4, which is going to give us 11. 2 times negative 2 is negative 4, plus 1 is equals negative 3. You're then going to have 16 minus 33. And your final answer when subbing x equals negative 2 into this derivative is negative 17. Our next example is an example from the sinusoidal unit. And it is sine squared x times cos squared x. For this, f primed at x is going to be equal to 2 sine x cos x, as the derivative of sine x is cos x, times cos squared x plus our f of x value, which is sine squared x, times 2 cos x negative sine x, as negative sine x is the derivative of cos of x. The next line of this equation is going to be 2 sine x cos x times cos squared x is cos cubed x, minus sine squared x cosine x is sine cubed x times 2 cos x. We can then find a common factor of 2 sine x cos x, and we are left with taking one of those out, cos squared x minus sine squared x. These are both well-known trig identities. 2 sine x cos x simplifies to sine 2x, and cos squared x minus sine squared x simplifies to cos 2x. And that is our final answer for that derivative. Our next example gets more difficult yet again, and it is f of x is equal to x cubed 3x plus 7 squared. F primed at x is equal to the derivative of just f of x, which is 3x squared plus times g of x, 3x plus 7 squared plus x cubed, and then you're going to take the derivative of the outer function, which is going to be 2 3x plus 7, all multiplied then by the derivative of the inner function, which is just going to be 3. This is then equal to 3x squared, 3x plus 7 squared, and then we're going to simplify the second half of this expression. So we're going to be left with 6x cubed, 3x plus 7. We can then factor out a 3x squared, 3x plus 7. Then inside our factor, we are going to be left with just a 3x plus 7 plus 2x. Then if we want to simplify what is inside our factor yet again, we are going to be left with 5x plus 7, which is our final answer. Our sixth example, we are going to take the derivative of a rational function using the product rule. So we have f of x is equal to x minus 4 over x squared minus x minus 2. This can be also written as x minus 4 multiplied by x squared minus x minus 2 to the negative 1 if you're moving that up to the numerator. Product rule of this function. So we are just left x minus 4, the derivative is 1, times x squared minus x minus 2 to the negative 1, plus x minus 4, and the derivative of this outer function would be negative 1, x squared minus x minus 2. Negative 1 minus 1 is negative 2, and then the derivative of this inner function is 2x minus 1. My marker is just running out here. But then we are going to make a common denominator to get rid of these negatives. So we are left with 1 over x squared minus x minus 2 plus x minus 4, 2x minus 1 all over x squared minus x minus 2 squared. We then have to find a common denominator, so we're going to have to multiply this by 2. So that would make our numerator x squared minus x minus 2 over x squared minus x minus 2 squared. Oh, sorry, I made a mistake. This is actually going to be a negative because of this. So this is going to be minus x minus 4 2x minus 1 over x squared minus x minus 2 all squared. We're then going to collect our like terms from this expression. No, pause. Before we do that, we are going to factor out this. So it's going to be x our next step is going to be x squared minus x minus 2 minus 2x squared, we're going to FOIL this out, minus x minus 8x minus 9x plus 4 all over x squared minus x minus 2 squared. This then, distributing this negative out, is going to be x squared minus x minus 2 minus 2x squared plus 9x minus 4 all over x squared minus x minus 2 squared. We're then going to collect our like terms, giving us x squared minus 2x squared negative x squared negative x plus 8x negative 2 minus 4 minus 6 all over x squared minus x minus 2 squared. And that is the derivative for that rational function. This example is getting harder again, and it's going to be an example from the logarithmic unit. And it is f of x is equal to x minus 1 squared e of x. F primed at x is then equal to the derivative of x minus 1 squared, which is 2x minus 1 times 1, since it's still the derivative of the inner function, e to the x, plus f of x, x minus 1, 2, and then we also learned that the derivative of e to the x is always still e to the x. And there we have applied our product rule. Then we have 2x minus 2 e to the x plus, and we can expand this out, so this is going to be x squared minus 2x plus 1 all e to the x. We can then factor out an e to the x, which would give us e to the x 2x minus 2 plus x squared minus 2x plus 1. Then collecting our like terms within the factor, we get x squared, since we always want to start with our highest exponent. X squared, 2x minus 2x gives us 0. Negative 2 plus 1 equals negative 1. That's our root word. Our last example is going to be using tan, which I thought was good since some people do find it a little more tricky. And it is f of x is equal to tan to the square root of 1 minus x. Derivative of this, the derivative of tan, which is our f of x value, is secant squared. And then multiplied by our g of x value is 1 minus x. Plus our tan eventually is going to eliminate. So the derivative of our 1 minus x is 1 over 2. As when you take the square root, you're left it's the same thing as 1 minus x to the 1 over 2. So you'd be left with 1 over 2, 1 minus x to the negative 1 over 2, as you would minus 1 over 2 from 1. And then you are left with the derivative of the inner function, which is negative 1. Then for our final answer, we don't want to have any negative exponents with it. So it is secant squared 1 minus x over 1 over 2, 1 minus x, 1 over 2, with a negative in front because of that negative 1. I hope you enjoyed this lesson on the product rule, and you now know more about it. Thanks for watching.